Supervised learning, what is you started, right? Reinforcement learning, we know the concept. So today what we want to do, we want to continue with the supervised learning, and in supervised learning we will talk about two very important things, which is called classification and regression. And we will talk about a particular way in the case of the classification. Remember, from the beginning of the course to the end of the course, I will deal and give examples on binary classifications. And all of these methods, by keep of the whole generality, you can extend it to multi-classifications. We do binary because it's easier to give an example, it's easier to show the formulas, but keep this one in your mind, you can always go and extend it. So let's start by talking about what is classification, what is regression. What is the difference between classification and regression?
In classification, we try to find the line that divides the data, and then in regression, we try to fit the data.
Well, in classification, we can put it in this form. Classification is discrete. You give some input values x, and we are mapping it to some discrete label. Males, females. All of you, if you do the face recognition, you are discrete labels, and you can do the face recognition. Whereas in regression, we are trying to approximate a function, a continuous function. So you have some input values. You put the input values on your graph. I'm supposed to use this. Like this, you have lots of data, and then I tell you that if this is my input, tell me what is the output. In order to find the output, we draw like the baseline, and we look at what is the value here, and we say that this is the value. So this is a regression. So the main difference between regression and the classification is that classification is doing some kind of mapping of the input on some discrete labels, which are the outputs that we have. In case of binary, true or false, male, female, tall, short, or it can be like multi-classes, like say Anton, Capri, Taui, and so on. And in the regression, what happens is that we are dealing with the continuous values. So we have a function, and we try to find out what is the new value based on the input values that we have. So usually, we will do an example, and you see that in the example, sometimes you can define the same scenario in a way that it can fit into classification. In other words, the output can be discrete, but the same scenario, someone else can define it in a way that the output will be continuous, so it will be regression. Today, we will talk about classification, and we will talk specifically about the method called decision tree. But in order to do that, we have to do a few definitions. But let's do one quiz on the slides. And by quiz means that we understand what is the classification, what is the regression. Let's see if we understand it correctly or not. And the quiz is this. Here we have the inputs, here we have the outputs, and here we want to find out if they are classification. What we want to do is classification or regression. Look, for both of them I have an input, I have an output. And if I am mapping it, and I look at the whole scenario, I have to make the decision if it is a classification or if it is regression. Okay, let's start with Suma. Credit history. You know what is a credit history? The bank has a credit history. How much money I have, how much money I loaned before, what is the situation on my credit card, do I pay them back regularly, or I'm a very bad customer. So this is called a credit history. So the input is the credit history, and the output is that they want to lend me money or they don't lend me money. So is it a classification or a regression? It's a classification. Now, I have a person, a happy person, and what I want to do is this. I want to categorize this person if it is a high school person, or if it's a college person, or if it's an undergraduate or graduate level student. So, Eric, is it a classification or is it a regression?
Based on that the person is happy.
A very sad person. we have one person, and there is an algorithm which helps you to tell you if it is a high school or a college or a graduate student. So is it a classification or is it a regression? It's a classification. And finally, okay, you tell me that we have the same person, but this time my algorithm, my scenario works and it gives my actual age. That, not mine, but the person's actual age. So is it a classification or a regression?
Regression.
Now, that's true, that's a regression. But one thing that we have to note when we want to deal about if it's a classification or regression, we have, what do we look? Eric, you said that this is classification. What did you look to say that this is a classification?
We have discrete, we have labels.
We look at the output. We don't look at the input, what the input is. We don't look at the black box or the algorithm that you have. We look at the output, and as we said, if it is discrete, we say that this is a classification, and if it is not discrete, we call it regression. We understand that age is very tricky. In the sense, we can say that we are talking about human, so the age is between 0, let's say, to 200. So it's limited, and we can say that the ages can be like up to some specific number. In other words, you can consider discrete. Remember, discrete, I don't mean that it is integer numbers. Discrete means it's countable. So for the age, someone can say, let's say one can say and say, no, I can count and say that from 0 to 200, we have, let's say, 100,000 possibilities, and that's it. We don't have more. Then it will be a classification. But we understand that we can, this is kind of like a very political fight. So we consider this example as a regression. However, we know age can be also considered as classification based on how you define your scenario. So, what I said that in order to find this classification or regression, we have to look at the output. Now, before we proceed, there are 7 definitions, and we have to go through these definitions because we use these terms, so you need to understand. The first thing that we need to know is instance or input. What are instances? Tell me, what is the definition of an input? Don't read from there.
Input is that is the set of features that we feed into our algorithm.
They are features, or we call them vectors, that we feed them into our algorithm, that we have to handle them. They can be pictures, they can be audio voices. In the previous examples, they could be the credit score, whatever we have. So this is called the instance or the inputs. Now, what about the concept? Concept is a function that maps our input into the output. So concept is a function that maps whatever we have as an instance into whatever the output that we have. If we have a binary situation, you give the instance, you give the input or the feature to our concept, and the concept says that this is true or this is false. And the thing that we're trying to find, in other words, the method that we try to find the actual answer is called the target concepts. So, we have the concept, we have the target concept. Now, in order to tell the whole system that how we are finding the answer, we have to come up with something which is called hypothesis. Right? If you want to define something is short or tall, you have to define a limit and say that if it is above that, this is tall. If it is below that, it will be short. So this is considered to be a hypothesis. Now, when we are dealing with machine learning, and when we have lots of lots of inputs, then we sometimes find out testing and dealing with them is very time consuming, because if you assume you have 7 billions of some data, working on them is not very easy. So what we do, we take some samples. So what are samples? Sample is something that you already use it in your homework, and we call it training set. They are well-labeled input data. In other words, we call it labeled in the sense that we know that what is the right answer. I make a face recognition system, and I use your faces as a training set because I know that if this picture is Ernie or this picture is Kurt, I already know them. So if I give Kurt into the system, I know that what it has to do. So I'm telling them, look at this one, this is called Kurt. Look at this one, this is called Eric, and so on. So these are called the samples or the training set. Now, what about the candidate? What about the candidate? You know, we define the sample, right? For the sample, we have a target concept which tells us that this is male, this is female, or yes, this belongs to this class, or no, it doesn't belong to this class. And this target concept is called the candidate. And finally, we have something which is called the training, the test set. What is the testing set? What's the difference between training and testing? That's part of the database or instance which are labeled. Already I know what is the answer. So I give them to the system to test whether I have a correct recognition rate or not. Do you know what can I gain from this test set?
Can you understand how if the algorithm is
It helps you to calculate the error. Because if I send a correct face, if I send, let's say, Anton, and the system says that this is not Anton, this is Suman, then it means that there is an error, so I can calculate the error. Now, one thing that we have to be careful, and people call it cheating in machine learning, is we should never use any of the testing set into the training. Why?
Because then it had the value that it's testing for.
Yeah, because then if you try to calculate any similarity, you see that it's exactly the same. In other words, if you use it, you will fail to generalize your technique. Imagine I have a very, very naive method, and the naive method that I have is this. I can recognize people based on hairstyle. And how I do it, I cut all the hairstyles I put in the training, and in order to test, I'm cutting again the same hairstyle which is already in there, and I say that, look, I put the hairstyle of Kurt, and the system said that is Kurt. This is a cheating machine learning because we cannot use the testing and training in the same place. They have to be well separated from each other. Now, we said that we will talk about very particular method in the classification. Still, we are not talking about regression. Regression will be like our next session. And the method that we want to talk is called decision tree. And in order to talk about decision tree, we will use an example to do it. And the example that we do is, imagine you and your date want to go to a restaurant. Okay? And the challenge is that whether you have to enter into the restaurant or you should not enter into the restaurant. Okay? Now, let's see what are the challenges. We understand that this is definitely a classification scenario, right? Because you go or not go. So you have discrete outputs. What are the things that you have to consider? There are millions of things that you can think of. Like the time. Time can affect on whether you want to go to a restaurant or not. And the atmosphere, if it is like a fancy restaurant, or if it's a casual restaurant, or if it's a romantic restaurant, whether it can affect on you whether you want to go there or not. If it is occupied or not. If it is a hot date in the sense that do you want to impress the person which is by you or not? Or if it costs, is it a cheap or expensive one? Or if you are hungry or not, or if it's raining outside or not. So there might be thousands of other things that you can write them down. We understand some of these things might not be relevant to you making a decision. For instance, number of cars which are parked in Tartu with high probability is irrelevant from whether you want to go into the restaurant or not. But someone can write it down. So in other words, all the things that I have written here as an example may not be relevant. Okay? So we have lots of instances, but some of them are not good ones. So we don't need to use them. So what we do, we will use all these instances, all these features that we have, and try to pick the best one in order to make a simple decision. And the decision is whether we want to go into the restaurant or not. Now, decision tree helps us in order to make the conclusion for this specific example. So as you can see, decision tree is actually a specific way of representing your idea of or solving the problem. So decision tree is representation. Now, we come with a representation, and when you have a representation, then you might have different way of writing down the algorithm. So this is something that you have to be very careful. Representation versus algorithm. So decision tree is a way of representation. When you have your representation, then it is up to you how you want to implement and make your own algorithm. So this is the general shape that we have for decision tree. We will get back to our example about dating in a few minutes. But this is the general shape of a decision tree. The first observation that we have that it is a tree, right? And it's a tree because it has the branches and it has the leaves. Now, what is the name of the first one? Or any of these ones is called the nodes. In the algorithm, possibly you have heard it. This is called the node. In machine learning, we call it that this is an attribute. Okay? And what about these ones? These branches are called edges. Or for us, there are values. What is the value of an attribute? In the dating example.
Yes, no.
In the dating example, if they are, okay, what are the nodes? If all of these things is what you have in your hand, can you tell me that, can you give me an example of a node in here? Sorry? The blue ones are the nodes. Okay? Let's pick up, let's pick up Hungary. Can you tell me that what are the values of Hungary?
Yes or no?
Yes or no? Very good. Eric, I am picking up the atmosphere. What are the values of the atmosphere? Yeah, so we have like three values. We don't need necessarily have to end up with two values. So here, in our example, it's kind of a binary, but you can see that sometimes we have only one single branch. I will draw for our examples, and then you will see that sometimes we have three. So this is called node, this is called edge or values. And the last one, which is not connected to anywhere, is called the leaves in tree. But in machine learning, we call it the output. So there are the attributes. These are the outputs. What are the outputs for us for this example of dating? Go or not go. And these ones are the values that we have. Now, the question in all type of trees is this: which attributes or which nodes do we have to pick? Now, usually we pick those attributes, we will see it later, that will help us to narrow down our data, right? Let's go to the example of dating that we have. The example of dating that we have. And we pick up, let's say, the first attribute to be hungry. Now, what happens in decision tree is this. The next attribute depends on the previous attributes that we have, the previous answer that we have. In other words, I can choose attribute 2 here if my answer was, let's say, no. Right? If my answer was yes, choosing this attribute will be either irrelevant or not logical. Right? For example, imagine this. You ask me a question, are you hungry? And I say yes. Then the next question is that, did you eat 1 minute ago? With high probability will not be logical, right? Because you already asked me if I am hungry and I tell you yes. So the questions that we have in these attributes, the attributes that we have actually depends on the value on these values that previously we answered. So let's do a quiz before we play a game, okay? And the quiz is this. I don't have a paper.
You can flip it.
Or you can write on the whiteboard. You can under.
No, I will use the whiteboard later for the game. And I am sure that everyone has a piece of paper and a pen as they come to the university. You might need them. Okay. And the example is this. Occupied, time, raining, hungry, hot day, happiness, and then class. True, false, true, false, true. Let's say this is a pizza, this is an Asian. This is Asian. Others, true, true. I have a very good handwriting. You have to be able to read it. Class. The last one is class. Decision. Okay. So this is the table that I have. And I have a very, I didn't want to use the board, but I need to. And I have a very specific decision tree. And the specific decision tree that I have is this. Occupied, time, and the happiness, okay. Please fill the class based on this decision tree, and then after 1 minute I will ask questions and I want you to answer. And you have this decision tree. You look at this decision tree, you look at this table, and you tell me what is the class. What are the classes, Igor? No. The classes are not to go or to go. That is the dating example. You are with your date, you want to make a decision. Do you want to go to the restaurant? No, I don't want to go to the restaurant. So it's a classification. Yes or no, not go or go. So for each of these ones, I will have to fill it.
That's quite interesting. So it's If it's not occupied, you don't go?
Yeah, I am a very social person. I feel very suspicious if there is no one in there.
So if like you can't sit, it's good.
Yeah.
Nobody
I
goes there.
with you. Okay, you have 15 more seconds.
Is there also like a mathematical way how to start it?
Which is the next slide.
Okay.
Okay, with Anton we start. What is the first one?
No.
Thanks, Anton. So it's a no go. Okay, Kadri?
No go.
No go. Let's also trace it. It said occupied true. So if it is occupied true, it means that I am in this part. So I have to go to the next question. And the question is about the type. And it asks what is the type pizza, which means we come here, which the decision is no go. And in case of the other one, is it occupied? False. So directly I go to the no-go situation. Okay, Tavi, you tell me the next.
No go.
Go.
Thanks, Tavi.
Let's go.
Oh, I didn't hear that. It isn't.
Go. Care.
No go.
No go. What's your name?
Jürgen.
Okay, Jürgen, tell me that.
Let's go.
It's go. Now, we understand that, as Tavi mentioned, there can be actually many trees, right? Question is that if I have many trees, which tree do I have to pick in order to have very good results? Let's put this question in another form, and this form is bad. I am using occupied, type, and happy. So, occupied, type, and happy. So these instances that I have, these inputs that I have, what can I say about these ones? They are irrelevant based on this tree. But I can come up, Eric can come up with another tree which actually look at the rainy, hungry, and hot day and make the decision whether to go or not to go. So questions that we have, the challenge that we have is actually this. What are, I have to raise this part, what are the attributes? What are the attributes that I have to choose to make the tree? What are all those trees? I mean, we have lots of trees. Which one is the best that can lead to a very good way of doing the classification? So in other words, if I have multi-decision tree for one set of instance, which of those decision trees are the best? In order to do it, we want to play a game, okay? And the game is a very well-known game, and it's called 20 Questions. And basically, I pick up something in my mind, right? And you will ask me yes/no questions. You have 20 choices, so you ask a yes/no questions, and by the end, either you will be able to guess what I thought, or you cannot guess what I thought, okay? So I switch off the 20 questions. I switch off the projector so I can use the board, or I can come here. This is very cool. Now, who is the volunteer to play the game with me? Okay, Anton, you can come here so you can be in the video. Okay, we start the 20 questions, right? Go ahead. Is it alive? Alive. It's a very tricky question. The answer is no. but it can be either an object now or it can be a dead person.
True.
Okay, anyway.
Is it an object?
Is it an object? The answer is no.
It's a dead person.
Is it material?
I tell you, a much more intelligent person, it is not an object. It means, can it be material? Is there any material which is not an object? So it's really very, I write it down because I can point out this later. Is it material? No.
Is it like feeling?
A dead person, is it a feeling? No.
It's a person, you gave it away. Good.
How do you ask your question? Do you look at these ones?
Yeah,
Good.
What did you understand when he asked if it's material?
Material, whatever material, but it doesn't have a part to it.
Does it mean like maybe he asked like whether it physically exists or not?
Yeah. Question also mean that.
Well, objects are also in there. Well, anyway, it's not
So
material.
are people.
Anyway, from these two we understand it's a dead person, so material will not be very relevant, but
So we're finding out who's the dead person.
Oh, because that person should be material because we can nudge it.
don't worry. Go ahead.
So we don't have that person.
We can,
Luckily.
from the tree, we can't tell that it's a person. You gave it away.
Yes, you understand. Look, is it alive? No. So it means dead. Is it object? No. So it's a person. So a dead person. So you have to follow like that, right? I mean, all of these ones should help you.
Yeah, but material.
Anyway, it's not material. Go ahead.
It doesn't change my answer.
Is it a dead person? No. Just a bit.
No, we don't try to do anything. He tries to ask questions.
Can you help?
No.
Why?
Let's have another volunteer. Okay, stop. I pick up something else. Another volunteer. Okay, David, come here. The winner will get 50 cents. I mean, a concert ticket for 50 cents. All right.
Is it alive?
Alive? No.
Was it alive?
Was it alive? Yes.
Was it a person?
Was it a person? Yes.
Did he die within 100 years from now? Looking backwards.
Yeah, let's put it this way. Is it a recent person or old person? Yes.
Recent person?
Yes, like died in less than 100 years ago. Don't worry, I'll tell you when.
Was this person on the east side of the planet, if you divide the planet, I don't know how to call it, like that half sphere, was on the east side of the
How do you want to divide? Like through England or through US? Because the east of the one is the west of the other.
Oh, okay. I want to divide the Earth by Atlantic Ocean, like in the middle of Atlantic Ocean.
Okay, you mean that, again, I can say, yes, it is on the east, and Japan is the east from the other.
Yes.
And it can be, no. It can be also in the west. Do you get the point?
Oh, yeah.
This point, is it on the right or left of the sphere? I can start on the left and get to this one, the right.
But if you know, if you have like that, you have to cut.
Usually what we do, we cut to the upper and lower hemisphere.
But on the like northern hemisphere or south?
Yes, northern or
South. Okay. So
southern,
then, like,
and I actually like northern.
Yeah, was it the northern hemisphere?
And then the answer is north.
So
That's
then
okay.
it was yes.
Yes, north.
So, was he living in Europe?
Europe? No.
Was he living in North America?
North America? Yes.
Was he a politician?
Politician? No.
Was he a scientist?
Scientist? No. What do you call it? A? I don't know. It's A.
What was it? Was it a maid?
A maid? Yes. Wow. No, this time is flipping.
Okay.
Last time.
So, was he famous?
A famous person? Yes.
Was he an actor?
An actor? Yes. Also an actor, let's put it that form.
Did he die within last 5 years? Or like maybe like
I
20?
don't know exactly.
So
So
is that right?
yeah, so I give you another question because I don't know it.
Did he die within last 20 years then? Or?
In the last 20 years, definitely.
He died within last 20 years.
Yes.
So that's between 1995 and now. Actors who died. So now I guess I would. Was he acting in movies or in TV? Was he acting in movies?
Like in movies, yeah, a few.
Was he acting in TV shows?
No.
Movies. Was he acting mostly in, or was he most famous for comedies or drama? Or was he most famous for comedies?
Let's ask this one. Famous for acting, and the
Was he
other
famous
is
for
no.
acting? No. What else would he be famous for? Was he? No, Robin Williams.
Four more.
Was he famous for sports?
Sport, definitely no.
What else would he be famous for? Was he famous for singing music?
Music, yes.
Was he a rock musician?
I am the worst person to tell you what is the type, but I know that he was on the right.
Last question.
Last question, and then you guess.
Was it Will Smith?
No, you have one more guess.
Oh, he's alive.
Till now, yes.
Yeah. Was it was the rapper, for example?
Rapper? No.
No.
Let's. Do you understand that what is the aim of this game that we are doing, apart from having fun in the class, is in decision tree we have nodes, we have attributes, and these are the attributes. Okay, and if you consider binary decision tree in specific example, these ones are the leaves, not the leaves. These are the edges, the values, and if the questions that we pick are not really from the consequence of the previous node, it can end into nowhere. Okay? And if the questions that we pick are intelligent enough, in other words, you pick this question because of the previous question, then, or the answer of the previous question, then you have higher probability to get to the answer. Now, I have one more color. So let's have one more person for the same scenario, but I'll definitely choose another thing in my mind. So you won't have like 40 questions. But let's this time the person who we volunteer to come here, he or she, I want them to think and the question make relevant question. Like many of these questions, we do understand that it seems like either they are not good attributes or they are not relevant to the previous questions, right? Anyway, who wants to be next? You have 5 more seconds before I come. Okay, Eric, you come here. And now I have what? Someone in my mind.
Okay.
Yeah.
So we're starting.
You have 20 questions. Live. No, today I'm dead stuff. Either objects or dead people.
What is an object?
An object. No.
Was it a he?
May. Yes.
Was he famous?
Famous. Yes.
Did he die in the past 20 years?
Die past 20. Yes.
Was he an artist?
An artist. No.
A scientist?
Scientist. No.
Actor?
An actor. No.
Politician?
Politician. No.
An entrepreneur?
Entrepreneur. I can't let us spell it. And
Businessman?
yes.
Was he rich?
Rich.
That's a billionaire.
Yes.
Was he a billionaire?
Bill. I don't know. Junior. I have to call this Switzerland bank. I thought. No.
So a millionaire. There are many of those.
Yeah, but billionaire, you have only one is Bill Gates, right? Who's still alive?
Was he did he get rich with technology?
Did he get rich with technology or a technoman? Yes.
Was it Steve Jobs?
Yes. He wasn't a billionaire, right? He was billionaire. He was billionaire.
Yes.
Billionaire, not billionaire.
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 Billion. Like a billion.
No, he died, and by the day that he died, he has about 48 million.
Yeah, but that happened stock.
But he didn't own all that. Okay, he had at 51, and he was at 40 something. Right now, if he was alive, he would be. But he is not a billionaire, I know. The only billionaire. Oh, I hope. Anyway.
There are many billionaires.
Yeah, I mean, I know just a few. Me, myself in the mirror.
Hey, was the previous one Michael Jackson?
Yes, it was Michael Jackson. Now, okay. Now, listen. Eric, why did you, and also Tony, why did you ask the question alive? Is it alive?
Can discriminate well, or like I can divide the data very well.
Yeah, you can split the data pretty very well, right? Then you are not looking for anything alive. Like definitely it will not be an animal or a plant or the human that we know, because they're all alive. So we go up for object, dead people, or anything in those categories. So it can split very well. Now, when we compare the black and the red questions, easily we can observe the relevance that we have in the red questions, and some of the points or the notes or attributes that we have in the black ones are kind of irrelevant. We know that this one was Michael Jackson, the black one was Michael Jackson. Look at the questions and see if any of these questions were kind of not really relevant. To me, was it alive was not a really good question. Maybe this is one of the places that trees start to go wrong. Then location, subject to question, again to me, because you know we have different trees for different solutions. And your tree may enter the results, mine also enter the result by a different approach. In my opinion, that was not also relevant. I'm not saying all the red questions were relevant, but it seems that red questions try to split the data in a very good form that come out with a few people. Okay, some people know that I love Steve Jobs, so the probability of choosing Steve Jobs is high, but there are, by the time that you come into here, you have a few dead, famous interpreters who are billionaires and became famous by technology. You have a few people, right? So, actually died in the last 20 years, I think the only one is Steve Jobs. The rest are still alive. Anyway, this is a very good example. This game was a very good game because we can see some of the attributes are not necessarily very good attributes. Okay? And question is, which attribute do I have to choose? And among all those three, which trees are the ones that guarantee me that I will get to the result? So in order to answer that one, I need to use the chair again. So, the questions, the first question that we have about being alive, we said it was a good question because it split data very well. The whole aim is that we have to choose those attributes which help us to narrow the possibility of the choices, right? If it is a famous person, or not a famous person, and understand that if it is famous, then Shahab's grandmother is not one of those possibilities. So we are narrowing down the possibilities quite a lot, right? So if you have lots of data, then you have to pick up those attributes as a nodes, which we are so sure that it can divide the data and split the data very well. We have another example, I mean, it's a small quiz that we do, and we understand that splitting the data is not any type of splitting. You have to split it based on some specific categories. So, now, in decision tree, we are adding one node on top of the other nodes in order to have further narrowing down. And I have put the further in the bold and also in blue. And the reason because of that is that the next node that we have, the next attribute that I pick, should depend on the answer of the previous question. If the previous question, with the answer we had this one, I erased it. But the first question was, what was your first question?
First was, is it alive or not?
Is it alive or not? And the second question was, is it an object? You understand? So kind of something that you could actually observe from the first one. In other words, your next attribute was not a good attribute because it was not depending on the answer of the previous questions. So you can win this 20 question if your next attribute depends on your answer. If they are independent, it means that you can actually interchange them. In other words, you can make a decision without having the other one. Like that example, I want to go to a restaurant or not, and then having how many cars are parked in part 2 is irrelevant. Even if you put it as one of the attributes, it will not help you to get to a very good result. Now, so in general, there are 4 very important steps that we have to follow. The first step is that we have to pick the best attribute. And by the best attribute, we mean that the one which can split the data very well. And the best way of splitting the data is divided into 2. Right? Because half of the data will go away each time that you are using it. The next one is we have to ask a question. We have to ask a question because the attributes that we have should be a question. Like, are you hungry? So we have to ask a question, and then we have to provide an answer. And these answers are those branches that I have, the edges that I have. Yes, if it is yes, I will follow different path, and if the answer is no, I will follow the different path. In other words, in the game that we had, if Eric was asked that if it is an object, is it a human or not, and if the answer was not, definitely he would never ask if it died or the person, the object died 20 years ago, because it was already an object, it was dead. You understand? So the question, the answer that I give will result into different paths. And then we go and we based on this answer, we will pick up the next attribute. So my answer, how far I will follow this loop till I get my final answer. Is it Steve Jobs? And the answer is yes. Or you are finished because the number of iterations is finished and you didn't get the results. So this is the general strategy that we follow. Here, what I've written in this slide is that the difference between the decision tree and actually the game that we did was, in the game you absolutely have no idea what I had picked. I could pick up anything, and I actually could cheat. And you see that if you are going close to the Steve Jobs, I could change it into, I don't know, another famous billionaire like Rockefeller. Now, quiz. I have an attribute, okay? And I have, Eric, I have question, which is in here, right? And based on the question, an attribute and question, I will get these ones. Rank, calculate, rank 1 to 3 to each of them. 1 is the best, and 3 is the worst attribute from these divisions. Which of these attribute is the best, you think?
It depends on what the stuff means.
Well, these are my data that I have.
I
Red
think
and
the
green.
third one seems to be best.
This one you pick number 1, okay?
The others, I'm not sure what does it mean your cloud doesn't have anything in it.
It doesn't have anything.
So nothing. So this is the worst.
So this is the worst.
Second.
We call this one second. Now, is there anyone, Abdulaziz, is there anyone who says this is not the best? This is actually the best. Do you know why this is the best? Because it gives me the answer. It gives me the answer. Why this is not the best? Why didn't you choose this one as the best?
Well, it has it has both of the stuff in it.
But you see that it has equal number. It divides into 2.
Yeah.
This is not the best because although we are splitting the data, we are dividing into 2, but we don't get any extra information, right? It's just like this. Is it taller, or can you put it in the classroom?
Yes and no.
You can say yes, and the answer of yes will not really give you any information in the sense that how big the classroom is. And also, you don't know if it is human or if it is an object or anything. So this is that type of question. It divides, but it does not introduce any extra information. Actually, we can give number 3 to this one. This is a scenario which causes something which is called overfitting. Can you hear me, Jürgen? Jürgen. Why, Jürgen? You move it up, right? Now, we said that one is not a good example. Is actually, you can put number 3 at the worst because it causes an overfitting. Do you know why it's an overfitting? Because whatever algorithm you apply here in order to split them, you have to duplicate it again here. Whereas you could use that algorithm once in here in order to split them. Imagine this is the best algorithm. In order to split it into answer like this, I have to have this one once in here, once in here. So it's actually increasing my number of tasks. This is basically irrelevant. Like I am asking the 20 questions, and the question that you ask is, can I speak? I mean, this is that. But in some cases, if you consider the concept of overfitting, that is even better than that one. Imagine this is my ultimate solution. I need to use this solution only once in here to get to the answer. But in here, I need to use it twice because badly I split my data into 2. But again, we can consider this one as 3, this one as 2. If I want to mark it, I call it 1, 3, 3. Okay? Because we understand that what is the problem that it causes. So, as I said, that one is causing an overfitting. Now, what we will talk in the next session is, we will continue to talk about decision tree, but we will talk about how expressive this decision tree is. And after that, we will follow by talking about the regression, and we understand decision tree is classification. And when we talk about regression, it means that now we are going to the continuous. We don't have a very discrete value. Now, do you have any question? If you have no question, this is the end of the lecture for today.